On 57, implicit differentiation to find the derivative of y with respect to x. All right, so let's go a term at a time here. We've got to take the derivative of x times e to the y. What rule? Product rule. Good thing you all knew that. First function times the derivative of the second. If the derivative of e to the u equals e to the u times the derivative of u, then the derivative of e to the y equals e to the y times the derivative of y. That's the first half of the product rule. Plus the second function, e to the y, times the derivative of the first. And the derivative of x is 1. You with me on the product rule? Then we take the derivative of negative 10x, which is negative 10. And then to take the derivative of 3y, it's the constant multiple rule. It's 3 times whatever the derivative of y equals. And what does the derivative of y equal? Y prime, or dy over dx. On the other side, the derivative of 0 is 0. So for the rest of the problem, we're just trying to solve it for y prime. All right? So I've got two y prime terms. I keep those on the left, and then I move my other terms to the other side. So I subtract e to the y from both sides. It shows up on the right, negative. I add 10 to both sides, so it shows up on the right, positive. All right, now on the left, I can't add those y prime terms together because they're unlike terms. But I can factor out a y prime. So that's what I do. Factor out y prime. I'm left with x e to the y plus 3 in the parentheses. I didn't do anything to the right side. Then to get y prime by itself, divide by what it's multiplied times. So divide both sides by x e to the y plus 3, and we've got it. Does that take care of 57? All right, what else? Which one? 7. All right, on 7, they want us to solve for x. All right, so what I did first was get the term with the x by itself. And then remember that natural log, or the natural logarithmic function and the natural exponential function are inverse functions. So that means that the natural log of e to the x equals x, and it means that e to the natural log of x equals x. So that's the key. Since they're inverse functions, let's take the natural log of both sides, as long as you have the same base. All right, and then the natural log of e to the negative x is negative x. So negative x equals the natural log of 3/5. Multiplied both sides by negative 1. X equals negative the natural log of 3/5. And then who knows what the simplest version of the answer is, right? I think that's fine. I think that's fine. I wouldn't leave my answer like that. I mean, it's correct, but it's kind of an in-between step between those two better-looking answers. And then the book said to write it to solve it to 3 decimal places. So to 3 decimal places, we got 0.511 when we type that in on our calculator. $48. Everybody had enough time on this one? All right, on 48, we're supposed to find the derivative, and they give us a function that is defined as a definite integral. So to take the derivative of that, it's going to be the second fundamental theorem of calculus. Now, I've worked out every little step here, but if you recall, we got to the point where we could do these things in just a couple steps, okay? And here's how we did it. We would say that f prime of x equals, all right, then it's f of u times the derivative of u, okay? So f of u, that'll be the natural log of, and instead of t plus 1, it needs to be u plus 1. So that's the f of u now times the derivative of u. Well, that's u. So the derivative of e to the u equals e to u times the derivative of u. So the derivative of e to the 2x equals e to the 2x times the derivative of 2x. So times e to the 2x times the derivative of 2x. And then clean it up a bit, and you'll get 2 e to the 2x times the natural log of e to the 2x plus 1. So that was just f of u times the derivative of u. Bless you. Okay, anything else? Yeah. 44. All right, here's 44. Are we just finding the derivative? Yep, find the derivative. All right. Now, I could quotient rule this, and there's nothing wrong with quotient ruling it, but I didn't, all right, because, and the only reason I didn't is because a 2 as your denominator, isn't that the same thing as 1/2 times the numerator? So I thought maybe it'd be a little simpler if I just did the constant multiple rule. So I rewrote it like that. So y prime equals 1/2 times, well, what's the derivative? Oh, wait a minute. I already took the derivative up here, didn't I? So in my head, I rewrote it like this. Then did the constant multiple rule, so 1/2 times, well, the derivative of e to the x is e to the x. Copy down the minus sign. The derivative of e to the negative x is e to the negative x times the derivative of negative x. So e to the negative x times -1. And then all you got to do, negative times negative is a positive, and either leave it as a coefficient of 1/2 or turn it back into a quotient. I don't care. Anything else? Okay. I've got a couple more examples to show you. So let's take a look at number 94. On 94, they want us to find the indefinite integral. So remember that the integral of e to the x dx equals e to the x plus c. The integral of e to the u du equals e to the u plus c. So on this one, we have 2e to the x minus 2e to the negative x over e to the x plus e to the negative x quantity squared. Well, this one's not just a simple, what's the integral of e to the u, is it? Looks like it probably requires a substitution. When we look for a change of variables, when we look for the u, we tend to look for quantities with an exponent. And then since we've learned about the natural log rule, we've looked for quantities in the denominator. Well, we have both. E to the x plus e to the negative x has an exponent on it, and it's in the denominator. So that's what I'm going to try. Let u equal e to the x plus e to the negative x. Now we have to figure out what du equals. The du is going to be the derivative of u, obviously. So The derivative of e to the x is e to the x. And the derivative of e to the negative x, we can do this in one step. The derivative of e to the negative x will be e to the negative x times the derivative of negative x. So it'll be e to the negative x times negative 1, or negative e to the negative x dx, which is exactly what we have in our numerator, so we're done with this part. Almost. Just multiply it by 2, right? And now I can replace the numerator. All right, so let's make our substitution, right? So our denominator, e to the x plus e to the negative x quantity squared, is now u squared. So we took care of that. And then the numerator times dx can be replaced by 2 du. Now, I could put the 2 here, but I'd rather put it up front, and I'll just do a times 1 because I can't leave it blank, du. You with me? All right, so we can work that. All right, either think of it as u to the negative 2 du or write it as u to the negative 2 du. I think I'll just think of it that way. So we've got the 2 out in front. Then I'm taking the antiderivative of u to the negative 2. So we add 1 to the exponent, makes it a negative 1. Now u to the negative 1 is the same thing as 1 over u. So that's adding 1 to the exponent, get u to the negative 1, or 1 over u. Then you have to divide your coefficient, divide your coefficient by the new exponent. So, same thing as multiplying by negative 1 plus c. Final answer. Where would the natural log come from? But that's this. Taking the integral of 1 over u squared is not the same thing as taking the integral of 1 over u. (104). Evaluate the definite integral, and then if you want to, you can use your calculator to make sure you got it right. All right, we need a substitution, I think. What do you think u should equal? Negative x squared over 2. Yeah, see, here's a new thing to throw into the mix, right? Quantity with exponents, quantity as your denominator. Well, we know how to find the integral of e to the u, so it could be the exponent of e. That's what's going to work this time. So let's let u equal negative x squared over 2. And you might want to think of that as negative 1/2 x squared, and all of a sudden finding its derivative seems easier. Okay? So what's the derivative of negative 1/2 x squared? So du equals negative x dx. Ooh, close. Yeah, all that's going to be my e to the u, right? So I need to replace x dx, and we've almost got it. Multiply both sides by negative 1, and we do. Now, I'm going to have to change the limits of integration, but the substitution is going to work now, isn't it? In this circle, that's an e to the u, and then the x dx is a negative du. So that part's going to work out just great. We got to change our limits of integration, though, because our limits of integration are x coordinates. We've changed everything to u, so we got to change them to u coordinates. So if x equals the square root of 2, because that's our upper limit of integration, what does u equal? Well, it equals negative 1/2 times the square root of 2 squared. Well, the square root of 2 squared is 2. Negative 1/2 times 2 is negative 1. All right, that's not so bad. Well, what happens if x equals 0? Well, if x equals 0, u equals negative 1/2 times 0 squared, which is 0. And we've completed our substitution. We've changed everything to u. We don't need to go back to x's. In fact, you'd screw it all up if you tried to go back to x's now. So we have negative the integral from 0 to negative 1. Does it bother you a little bit that it's from 0 to negative 1? Yeah, well, get over it. You could change it. You could flip your limits of integration and get rid of that negative sign in front. But here's the nice part. Keep that negative out in front. So we keep that as that. And then, what is the integral of e to the u du? E to the u plus c, but it's a definite integral instead of an indefinite integral, so it's just e to the u, evaluated from 0 to negative 1. Substitute in. Remember that e to the 0 equals 1. And then, who knows what the final answer ought to look like. I do like where I ended up. Like we've talked about before on the AP test, on the free response, you don't have to simplify that. If you got it to there, I think they would take it. All right, one more example. Find the particular solution that satisfies the initial condition. Now I'm going to put this whole thing up here on the screen so you can go back and look at the video once I get this posted. But you know the process, right? If you start with f double prime, take its integral, you'll get f prime. Use what they tell you about f prime, and you'll change your general solution of f prime into a particular solution of f prime. Once you have the particular solution for f prime, take its integral, that gives you the general solution for f double prime, then use your conditions, and that'll give you the particular solution for f, or for f. I said f double prime for f. Okay? So let me restate that because I messed it up. Once you have f prime, take its integral. That gives you the general solution for f. Once you have the general solution for f, use the conditions they tell you about f, that f of 0 equals 1/4, to get the particular solution for f. Okay? So, general solution for f prime, then particular solution for f prime. General solution for f, then particular solution for f. So here's what you need to do to finish off section 5.4. Page 357, do 65 through 79, 85 through 114, and 124 through 126.